High-performance computing used to be the domain of supercomputer labs and deep-pocketed enterprises, but not anymore. Matthew Shaxted, co-founder and CEO of Parallelworks, is tearing down these walls, putting massive compute power into the hands of scientists, engineers, and the AI community without the headache of being an IT plumber. In this episode, we dig into how their platform, Activate, is cutting cloud costs, escaping VMware lock-in, and redefining HPC for the AI era. This is episode 103 of Great Things with Great Tech with Parallelworks. Hey, Matthew, welcome to episode 103 of Great Things with Great Tech. It's great to have you here. And before we get into all things parallel, let's talk about yourself. Background in civil and structural engineering, so you're a smart guy for sure. But tell us, how you got started in this world and how you came to found this company.
Great. Yeah, Anthony, good to be here. Thanks for having me. Good question. I started actually, as you kind of said, a practitioner in engineering companies. I was working for large architecture engineering companies that design big buildings across the globe, Burj Khalifa, these type of things, Mural, it's called, and some other ones in a similar vein. And my job in these companies was to run computing simulations. My job was to take different designs or iterations of either a building or a campus or city and run them through really physics codes at the end of the day, which is kind of what high performance computing is all about. You're running simulations on physics to try to replicate some type of problem in the real world. And what I would do is I would take computers that were in the organization that we had, and they were actually old render farms that I was able to kind of piece together.
Okay. Yep.
I think about like 30 of them or something is how I started.
What sort of time frame was this?
This was like 15 years ago. So
okay.
When was that? That was right when I graduated.
2010 now, college. Yeah, 2010. It sounds like it should be
something
more,
like that.
It's
yeah.
2010.
Something like that. And I was basically, I put all these individual computers together. A problem, came in, and I'd say, all right, I can use this particular simulation tool to try to solve maybe like the structural optimization. How much, can you minimize structural output to save on, volume of concrete or whatever it is. There's problems like that. Or how can you position the facade to get the most sun hitting it so you can maximize solar output, for example. Right. So it was problems like that, all different
pretty
kinds.
Important
actually.
Stuff, right? For buildings, this is critical.
Well, everybody has different ways of doing this. This was like high performance design, they called it. So that was the world that was in. It was always trying to like optimize for costs or, some output. So basically, long story short, you start running these physics codes on a set of computers, and I was running kind of what they call Monte Carlo simulations, where you're testing different varieties of a solution space, and then you're trying to figure out which one gives you the optimal. So you do that, you run a lot of different iterations, 30 computers lets you run a certain number of iterations, and then you want to run more. So where do you go to run more? The US has, I think, about 5 leadership computing facilities or so. I actually got to update the exact number. But they have these leadership computing facilities where they build the large supercomputing systems across the country for researchers and practitioners. And Argonne National Lab is one, Oak Ridge is one, PNNL, I believe, is one. There's several of them. And I went over to Argonne National Lab because I live in Chicago, and it's, an hour drive away.
Okay.
And started my journey of getting into high performance computing. And
right.
you go there, you kind of tour the big floor, they're building size computers. So you see, racks and racks of these computers.
Yeah.
And, I was able to meet my partner, Mike Wild, who was a principal investigator there for many years, building a piece of technology that helps people like me, researchers and engineers, scale up their simulation codes on these big systems, and started working on that. And I remember very clearly, first time running a large HPC job, I was in my office late at night, clicked a button, spun up 20,000 cores on one of
Okay.
a cray machine.
These are
And
some big systems. These are some big super, they're proper
yeah, they're big.
supercomputers.
They're building, building size. They take up several floors. And that, you run more simulations than you have in your entire, in my entire life at the time. And I was like, wow, that's really powerful technology. Well, how can we bring that to more organizations? And that's kind of what started our thinking about, what, let's create a company about this together. Yeah.
So just going before we talk about Parallel Works and the starting of the company, what got you into that computing sort of angle before? Was it something that you just through college, through university, that just was natural
You
to
know,
you, or
yeah, that's a good question. I'm thinking back. I did a lot of programming in college. I went to Northwestern, did a lot of programming, kind of more for fun type
Mhm.
things. And actually, I remember pretty clearly. I went to a conference. It was a National Science Foundation summit of some kind in Chicago, and someone presented there who was my first boss. Actually, he presented this simulated city of Chicago. Actually, is what he was presenting.
Okay,
And I remember looking at that, like when he was presenting, I was like, wow, that's so cool. Being able to like use data and, physics and simulations to inform improving spaces and improving, environments. And I actually went up to him after, and that's how I got my first job out of
wow,
college. So it was kind of like that. And then that took me into this world of using physics codes and simulation in the built environment. And then it kind of broadened out from there to more, I'd say, computing in many different disciplines.
yeah. So I mean, because we're talking about if we're talking about mid 2000s to the 2010s and whatnot, we still haven't entered the era of GPUs as anything more than gaming or even anything really more
Hmm.
serious than what they were. Right, there wasn't that lab moment that we all kind of know happened with that researcher that got his son's compute graphics card and it computed stuff like a million times quicker, and then everything
Hmm.
kind of went from there. But so when you talked about being in doing these models and 30 sort of computers on site for those projects, they were just standard computers, and that's why you had to go to that supercomputer setup to do things quicker and better and faster.
That's correct. Yeah, these were really old Windows boxes that were part of a render farm at the time. So they were just literally
Right.
30 desktops that were just sitting around and nobody
Yeah.
was really using them essentially. And, I was able to kind of take those and put Linux on all of them and use them as kind of an internal cluster for, this type of computing simulation work.
Yeah. Excellent. So,
Yeah.
okay, so let's talk about parallel work. So, out of Argonne National Laboratory, you've met your partner there. So, what's the
Hmm.
first sort of spark and what's the problem? I mean, we can kind of gather what the problem statement is, but
Yep.
what is the problem statement and the founding principle for works?
Yeah, I mean, our job and our goal from the very beginning, and even it's true today, it's to improve the usability of big computing environments. That's the goal of what we've been doing. And really since the beginning, it was the same goal. We started as a user interface on top of these big batch scheduler HPC
Okay.
systems. And over 10 years, as computing environments inside of organizations has evolved, we've evolved along with it. But the main goal is to make computing more usable for, organizations that want to use these things for the critical parts of their business. Whether it's, traditionally for us, it's been a lot of R&D and enterprise research
Hmm.
domains, kind of like the type of applications I was describing, but in, different disciplines. And more, I'd say over the last 12, 18 months, as GPUs and accelerators are really kind of finding their way into organizations, it's been kind of evolving into that world because that's what, the organizations you wouldn't think of as a typical kind of computing consumer are buying these type of systems and need to use them for critical parts of their business. So it's the
Yeah.
same type of goal.
Yeah, because early on, like we're talking of those time frames, obviously machine learning, I mean, everyone thinks AI is something that's popped up over the last 4 or 5 years, right? But clearly it's been around for a lot longer than that. And
Hmm.
obviously we always used to hear about AI and ML, machine learning and HPC, big clusters, big number crunching. That's been around for a while. But, my whole, view on it, having been and seeing elements of it in the industry is that it's very siloed and it's pockets of high performance compute. And can you get access to
Hmm.
this? Can you get access to that? And then there might be some shadow IT happening as well, where one department might get access to something else and the other. So what you've done is come in and create that overlay or that and that UI and that user experience to democratize that effectively.
You got it. And actually democratize, large computing environments was our slogan way up 10 years ago,
There,
this
there
idea
you
of
go.
democratizing it. I mean, so just building on what you just said though,
Hmm.
there is pockets of it. There's different within an organization, kind of large or small. There's certain groups of users that need to use the computing environments for certain reasons. There may be a team that needs to do what I was doing and simulate some things to kind of get an answer. There may be analysts that need to use, Jupyter notebooks for number crunching and, analytic, analysis on data they're bringing in. A lot of, there's machine learning groups and AI groups now that are training, models, or using AI applications depending on where they're at in their journey, the organization's journey, to try to bring value into some aspect, either front of office or back of office or whatever it is. And exactly right. These things right now, they're pocketed in the type of computing environment that they need. So if you're running in, the data analytics, they're maybe running in their virtualized environments and they're going into their VMware or OpenStack, and the infrastructure teams that are supporting these end users within the organization can kind of give them access as they need it.
Hmm.
Maybe you have certain groups that need cloud resources. And again, the infrastructure teams have to kind of spin up, cloud environments and secure them. And oh, okay, you can only spend $10,000 here and kind of turn it over. Same with batch scheduler systems and the HPC. They're all kind of existing in these pockets or silos. And that brings a lot of complexity. And I always kind of say this, it's complexity for the infrastructure teams that are supporting the users and the CIO, CTO levels, depending where they're rolling up into. And then it's complexity for the end users. They're having to
Mm.
kind of whiplash around into like, oh, I'm in my terminal Slurm scheduler cluster now versus like, oh, now I'm in, AWS and I need some instances to do this. There's this whiplashing. So we're trying to kind of cut through that complexity and deliver a unified experience both for the end users accessing this stuff and the infrastructure team supporting them.
That's interesting because obviously it creates headaches on both sides, right? It creates headaches for the infrastructure team because they have to support these crazy requests from from these typically people that are very needy and not trying to say all researchers and that sort of stuff are like that, but obviously they just want they just want to do what they want to do, right? And
Yeah.
then you've got the other infrastructure guys who need to support this, but then they're probably thinking about scale, costs, efficiencies,
Or
clustering power, all
expertise. It's
sorts.
like, oh,
Yeah,
we got to go into Azure now. We've traditionally been an AWS shop, for example, and now
yeah,
we have to go to Azure or Google. It really is a different paradigm on how they handle roles and permissions and really allocation of resources, and billing is kind of different. So everyone is different. And these groups say, okay, well, how do we do that? Do we need a Azure expert now or a Google expert or something?
yeah,
And we're trying to say you don't really need to do that, when you use a control plane like what we have. And I didn't really introduce exactly it, but yeah, that's kind of the
yeah.
problem we're.
Yeah, I think we'll get to the whole aspect of what it is in a second as well, because
Yep.
it's obviously important to level set that in terms of what it is. Because even I've got a question relating to that. But and then on like infrastructure on the flip side, you've got the actual users who are wanting to consume the compute and consume the resources to do what they've got to do to get their outcome. They don't want to have to deal with knowing the ins and outs of starting an EC2 instance
I like to say
or a
they,
data
they
lake or
don't want to,
something.
they don't necessarily need to be the plumbers. I kind of say not everybody
Yeah,
likes that analogy, but like they don't need to, they'd rather go in and just get something to focus on the model they're building or the problem they're solving, and not necessarily the, provisioning call needed to kind of get that Amazon instance up and running and secured or whatever. That's kind of the
yeah.
difference. Yep.
So through these early years, founded in 2015, and then obviously, working through up until say 2022, 23, was it just that platform? Was it called anything specifically? Because now it's Activate, right? And we're gonna talk about the new evolution of that later on as well. But what was it effectively before? Was it just the UI? When did
Yeah, and it's
Activate come into
interesting,
play?
even as a company, right? We were, very lightly capitalized, right? We took a little bit of seed funding and then we kind of built ourselves up from customers
Hmm.
and some grants. That's kind of how
Yeah,
really
great
the
way to do it.
first, yeah, well, there's pros and cons, Yeah, that's the way we went. Yeah. And so really, I mean, like 6 years or 5, 6 years after the founding, I mean, we were a fairly small team that was delivering, building this product out and trying to kind of find our fit in the market. And, again, moving out of the batch scheduler world where we kind of started around that time, 2019, 2020, cloud was kind of really becoming competitive performance-wise
Hmm.
with these on-prem supercomputing systems. So you can go to the
Okay.
clouds, and it was, AWS, Azure, Google, for example. You can set up the infrastructure on those clouds in such a way, from a networking, a storage perspective, the hardware they actually have on the floor that could, and then their interconnect bypasses, EFA, or everyone has one. Azure had InfiniBand on the floor around that time. They just started rolling that out. You could actually get those things to perform in a way that was similar performance to these on-prem supercomputing systems.
Yeah.
And that was kind of a turning point for us because we started
Okay.
provisioning cloud resources at that time and trying to match performance to these on-prem systems. And naturally, we're starting to run hybrid then. So, but really during this time, we're like finding our fit. We were a small team, 5, 6 people maybe for, years, and was working with a handful of customers on kind of solving their specific challenges, but iterating as we go. It was kind of very much a discovery period, I would say. It's what does our platform need to do to deliver value to the broader kind of enterprise adoption ecosystem, initially again in that enterprise research domain. Yeah, that was the first 6 years. And then that evolved into now actually formalizing the product and really finding the fit maybe around 2022-ish.
Okay.
We had some big kind of first customer, I'd say big customer wins on recurring subscriptions and things like that.
Yeah.
We
Which is
branded
in
the
the public
product.
cloud. Like, so this is like, so you're starting to see consumption of public clouds because to your point, they're starting to be used more because they are as performant as on-prem. And so they're being used because they're seen to be a little bit more efficient. But that
Yeah, we were
management
really
layer
helping.
still wasn't there.
Exactly. Yeah, we were helping a handful of organizations with their cloud programs. That's kind of what I say. Like we were helping them operationalize their cloud programs, which what that means in my head is like they want to bring cloud to, and this is specifically kind of HPC cloud to large users across the organization. And they want to do that. They were doing it in kind of an enterprise shared model. They buy a certain number of cloud cycles every year.
Yep.
They want to distribute those across, hundreds or even thousands of users in a way that is controlled. And that's kind
Understood.
of what we started helping these organizations do. And I think where we kind of play the most value even today.
Yeah. And is it a SaaS platform? I guess we haven't really talked about exactly how
Yeah,
it's
yeah.
how it's offered. Yeah.
So yeah, the platform, the software that we build and sell, and since really the beginning, but it's been rebuilt several times. It's called Activate. We have a commercial SaaS version,
Mhm.
sits in commercial cloud, kind of non-CUI, non-controlled and classified environment. We sit over there. And then we have a FedRAMP High IL5 version of Activate that we call
Okay.
Activate High Security Platform, or HSP. That is for Department of Defense and alliance partners. Anybody on a DoD contract is able to use that platform, and then
Mhm.
we can, we're rolling out other FedRAMP versions as we speak. So
Yep.
those are our two managed SaaS environments. They're kind of the easy button.
Yep.
We're not a cloud reseller, we're just a software company. So you plug your own cloud credentials into these accounts.
Yes.
There's a little bit of a difference in the IL5 high platform, but generally you plug them in and we're acting as an orchestrator inside of your own accounts. We're
Great way to
not really
describe it, actually.
reselling cloud cycles.
Okay.
Yep.
Yeah. Orchestration is a good way to look at it, and what I thought it was actually doing. So it's not going to come in and take over, say, someone using, I don't know, like CloudStack or OpenStack or whatever it is. It's going to augment that to basically
Yeah.
level up and bring to someone's attention someone doing certain HPC, AI, high performance computing
Yeah, I like,
work.
we build on top of whatever infrastructure and cluster managers are already there. So we're
Yep.
not trying to like replace Kubernetes. We're not trying, we're augment or OpenStack or VMware, or we're augmenting those by providing kind of like the way to put guardrails around all these different environments and roll them out
Yep.
to a large user base. It's building on top of those things with specific capabilities like access, user access, unifying the environments. We do like allocation and quota enforcement
Okay. Yep.
at the
It's
scale of an
important.
organization. And then we run these workflows that, if you can run a workflow in our platform, which is all YAML-based workflow framework, kind of like GitHub Actions, it will run on any of the systems that you have connected into it. So it's kind of a
Okay.
unifying place where, oh, great, this organization has HPC systems, it has OpenStack virtualization clusters, it has AWS and Google, for example, cloud, and they're rolling in Kubernetes. We can bring all those things into one and then roll them out to the organization.
Are you able then
So
to distribute the workloads and those runbooks across different platforms as needed, but also potentially distribute it in itself? So you can use the power of all of these platforms for one particular workflow, or is that kind
yeah,
of
you can. You actually can, and we do that quite so, we kind of say this is our policy, engine in a
Mhm.
way where right now at the workflow level, you're able to set policies that say, hey, try to run on this on-prem system first. If I can't get the resources in that time due to capacity or maintenance or what outages, whatever it is, go and run it in this second or third location. We do those type of things today. We're moving in a direction that would be a little bit more intelligent about how computing tasks are actually routed to these different locations. But that's kind of a near-term roadmap item, kind of towards the end of the year. Yep.
Yeah, okay. And you talked about the DoD side of things as well. That's obviously very important. The HSP IL5 certification. Um, we understand exactly actually, some people might not because I think I do because I work within software within a company that's US based and the importance of being certified for US specific DoD. But maybe just explain why that is necessary for people that are outside of the sphere of the US.
Sure, yeah. It's and most people have heard of FedRAMP in some capacity, and really what it is a checklist of a certain number of items that you need to demonstrate that you're either, if you're getting an infrastructure or platform as a service or software as a service authorization, you need to demonstrate that your environment meets the requirements, these checklist items. They call them controls, right?
Mhm.
And as you go up in the stack of security levels or compliance levels, FedRAMP low, moderate, high, which then map to the Department of Defense. They call them impact levels, but they map to that.
Yep.
It gets more and more difficult to do that. So a FedRAMP high impact level 5 authorization, which is what we got about not even a month ago, took us about 2.5 years,
Wow.
unfortunately.
Yeah.
Um, it's really a checklist of about 400 items
Yep.
that our managed environment, our software running in it, everything that users can do inside of it has to meet these 400 items, and then we have to document it and audit it and have them check it, is what that
Yep.
means.
Yeah, and I
Yep.
think I went through a similar thing. We call it IRAP here in Australia, so for government
Okay.
contract and whatever. So again, different sort of levels, and again, a whole bunch of controls which you have to adhere to. So I think every country, every jurisdiction has a version of that. But obviously,
Yep.
a lot of software being focused in on the states obviously needs to have that. It's kind of like a
I'm
holy
guessing
grail.
there's similar
Otherwise,
requirements though, where it's like
yeah,
it's it's really a checklist, and then you got to have a big documentation package. I think our documentation package is like 2,000 pages.
yeah.
Where
And someone comes in and does an audit, and you've got to work through it.
Yep.
Yep, yep, yeah.
So and then you asked
It's
why is it
important.
important? Why
Yeah.
so why is it important? It's because the work that you're allowed to do. So, we talked about end users using these computing systems to actually get work done, whether it's like training a machine learning model or it's, running physics codes for some problem they're trying to solve in a virtual space. You can do certain sets of work in these environments that you cannot do in the commercial environments,
Yeah.
right? So it's in this particular level, they call it controlled unclassified. So it's CUI, which is like ITAR, so export controlled, where it's US citizens and alliance partners in some capacities that are able to go into this environment and run with certain sets of data and software that are not available in the broader ecosystem, commercial ecosystem. And there's, I got a whole bunch of examples of things you can kind of do in that environment that you can't do in the commercial side.
Yeah. So that's for government. So in terms of like your clients and whatnot, who you're serving outside of government? Who's a
Mhm.
typical sort of customer for you guys outside of the government stuff?
Yeah, so we've had a lot of success in certain vertical markets over the years, and there's certain reasons for that, but it's traditionally now it's been a lot of enterprise research organizations where they're
Hmm.
using computing both on-prem and in the cloud. So I call that hybrid computing. They're using hybrid environments to serve a user base. The markets or verticals that we've had the most success with are the ones that really build their own tools or they're using open source tools and they're not kind of limited on a ISV software license basis. Because we kind of bring value when people can come in and spin up large amounts of these things or support a
Okay.
user base that can spin up a lot of things. And some domains, like digital engineering is a good example where they're
Oh
very
yeah.
ingrained in the Ansys's and Siemens and Dassault's of the world, where those ISV software licenses become a big part of the expense in a computing environment. Very big. I'm not going to say a number. I have one in my head, but and each one is kind of its own ecosystem. So there's other companies out there that have really focused a lot more in that type of world. We've been kind of focused in, financial services. It's actually a lot of space tech customers that are using
Okay.
us to collect data from satellites and then they plug them into workloads on our platform to distribute across, hybrid computing resources, public sector, that's academic, but then also Fed Civ, government side.
Yeah.
Um, weather companies have been,
Oh yeah.
seen as
So I'm
kind
just
of
getting
similar as,
so companies that require the crunching of a tremendous amount of data, effectively.
yeah, and it's not actually always because you look in a large organization, there's usually a wide range of users. There's users that are super advanced, right? And they've been running inside of terminals and they just want access to larger scale resources to crunch their numbers. And they've been doing that for decades. And, our system supports them. But more and more, a lot of users are going into a platform like ours and they want just a way to get like a Jupyter notebook or a Jupyter Lab on a large set of maybe GPU accelerators.
Okay.
And they want to
And
do that without
just out of
having to
interest,
spend that.
what is the because I've seen Jupyter Lab pop up there and it's in a lot of your videos as well. So just for the people that don't know, what is Jupyter Labs?
It's kind of one of the, I'd say, main flavor du jours of ML and AI researchers building the models. And it
Nice.
gives you an interactive interface, a user interface that lets you go in and write snippets of Python code in separate steps. And you can kind
Okay.
of create these notebooks and share them. And it's an easier way to interact with really Python code, I would say. And they
Okay.
have different kernels as well. So yeah.
Yeah. And then that then obviously consumes the processing power at the other end of it to do its thing.
Yeah, so like our platform lets, again, these infrastructure teams that are maybe supporting 10, 30, 50, 1,000 users, 10,000 in some cases, it depends. It gives them a place where they could say, hey, now all these users can come in, click a button, get a Jupyter Lab running on, our big on-prem GPU system we just bought, or the one that we're renting out from, CoreWeave or Vultr or whatever the, neo clouds they're using. It
Yeah.
makes it easy to disseminate those things and there's a lot of different, a lot of different tools. People may want to run H2O or R Studio or whatever these things are to build their models, and we let them kind of send those tools out to the user base.
Yeah. I just wanted to go back. You mentioned abstracting schedulers, and I was just thinking about what that actually means. I'm seeing those being, and you kind of mentioned it sort of an old school way of doing things versus a modern way. That's how I kind of picked it up. But what did you mean by, abstracting the schedulers and moving into this modern sort of way of doing the processing?
Yeah, sure. Yeah, I mean, business as usual today, or practitioners today go into a computing environment and you're interacting with whatever the interface to the computing environment is. So different environments have different interfaces and I kind of classify that as a scheduler, but I think sometimes people call it different things. But a scheduler may be like, it's a virtualized cluster. They may be running VMware or OpenStack, and you get these resources and you can kind of assemble them in whatever you want to do, or you get one virtual machine and you can run it. That's kind of an interface. Um, Kubernetes. is rolling out with a lot of the accelerator clusters. It's kind of the flavor du jour a bit for production containerized workloads today.
Hmm.
That isn't when someone gets access to a Kubernetes cluster because they want to deploy their workloads or they're doing development inside of that, they need to interact with kube control. That's the interface you're using to interact with that cluster. In these HPC systems, a lot of people are running Slurm or PBS schedulers or LSF. They're different flavors of it. You go into a terminal and you have to write these commands to interact with the computing systems underneath it. So
Yeah,
this is kind of what I mean by scheduler. When I say our system abstracts away these schedulers, we kind of sit as a layer on top of it that translates the computing tasks
got it.
onto those computing schedulers. So it's like, oh, you want to run this containerized workload and submit it on your Kubernetes cluster. We kind of handle some of that translation layer between it to the actual Kubernetes kube control command.
Yeah,
Or
okay.
in the case of Slurm, it's like, oh, you want to run this job on a big, set of Slurm compute nodes. We'll handle that abstraction or the translation of the task, writing the actual batch file and submitting it onto the cluster. So, and what that means is that the end users don't necessarily need to do that, right? It's
Yeah,
kind of taken care of.
yeah, makes sense. We've got a little bit of time left. I want to sort of go towards the end and where the future is for you guys and what you're looking to do. But firstly, I wanted to ask a question about not AI just yet, but more about, you mentioned customers who have moved from on-prem to the cloud in that period of time. Have you seen the pull back to that repatriation happening over the last couple of years? Is that something that you're seeing? And obviously you're able to support that because it's almost like an
It sounds like
inverse
you
of
may
where
be
you
seeing.
started.
Are you seeing that as well? Yeah, because
Absolutely. Well, yeah, absolutely.
yeah,
It is happening, right, for sure. And it's interesting to see because you kind of started on-prem and sort of did expand it to the cloud, but is it pulling back is really the
it's
question.
we are absolutely seeing it pull back and
Yeah.
repatriate out. I think the conditions of that is that some of the groups that we're talking to or future customers, and I'm sure we're fairly small and obscure right now, so it's there's probably way more organizations going through this even right now where they've
Mm.
they've made that movement from colo or data center into the cloud, and in some cases went all in, and these cloud environments become very large to
Yep.
the point, from a spending perspective and economic perspective, where now they can justify bringing it back on-prem because it is, when you operate these things the right way, on-prem resources and environments the right way, they are less expensive. That's kind of common knowledge, and there's different people debate how much less. So that is happening. We're actually supporting customers now that are wanting to migrate their workloads back into an on-prem, colo or a data center, but they
Okay.
want to match the user experiences in the cloud they're running today and
Yeah.
still have the opportunity to burst out. So we kind of
Yep.
fit right into that world. Yeah.
And being that overlay sets you up perfectly for that.
That's kind of a big purpose. It's kind of, a group that's wanting to do that. We can say, hey, great, we'll just start in your cloud environment. You can, keep running everything you're doing now. We'll run it in the cloud. And then, oh, your colo or your on-prem data center just came online. To us, it just plugs right in to the Activate platform, and you can start moving tasks over there. And, again, have these policies that say go run over there first. And if you don't have capacity, go burst out to your existing environment. We're seeing a
Yeah.
lot of demand for that. Yeah.
Yeah. Right.
Which is, it's like a
Just
cyclical world, right?
yeah, it'll pull back at some point and go the other way again for sure. And also, yeah, how's the rise of the hardcore GPU system? How is that? How have you seen that impact high performance computing or just general, I guess, parallel processing
Yeah.
in a way? And therein lies your name, I guess, as well. I didn't really ask about the name and how it came to be, but just very
Yeah.
quickly, how did the name come to be? Let's. I
It,
usually
it
ask at
came
the
up
start.
as, we were a high performance computing parallel processing
Yeah.
software. And we were like, what's a good name for that? And we kind of landed on Parallel Works. And I remember we were like looking at what domains are open 10 years ago now. And that one kind of just stuck and we ran with it. So it
There
was
you go.
that theme of workflows for parallel computing. And,
Yeah.
that
Excellent.
Parallel Works. Yeah.
All right, so let's finish
On
off
the AI
with that.
side,
Let's get into AI and work out exactly where you finish, because I believe this is where you're obviously, focusing a little bit of effort in now.
yeah. So actually, not long ago, we launched basically a new set of capabilities on our Activate platform. So we call it Activate AI, and it really boils down to three things. It's direct Kubernetes support. So
Okay.
organizations can plug in their existing Kubernetes clusters, either on-prem or in one of the hyperscale clouds or in a neo cloud, wherever they are. And we're handling very specific things on top of the Kubernetes environment to make it usable across a large or, an organization. Again, it's like
Okay.
operationalizing the clusters. So the things we're doing there, it's when we're doing kind of user management and access control for the Kubernetes resource. Who's able to get to them? We're doing allocation and resource quotas, through, dynamically in our platform where you can set up these, allocations or resource quotas. Those authenticated users are able to actually get a kube control file out and all the authentications taking place. We're allowing these infrastructure teams to actually put rates, dollar rates on their, currency rates on their CPU, RAM, GPU, and storage resources as part of the cluster. And they can charge back the resources across an organization because we're seeing
Right.
a demand for groups that want to actually say, hey, this project can spend $10,000 on the cluster, regardless if it's their on-prem or if it's in a hyperscale cloud. We're letting them actually do that. We're doing MIG fractionalization, and we're partnering with a company called Juice Labs for non-MIG supported pooling of GPUs, so fractionalizing GPUs out.
Okay, which is
And
quite
then
important in Kubernetes world, right? As containers become containers, they're
it's
fractionalized
important.
VMs and well, right? Like,
It's important for organizations that want to be able to make GPUs available without giving a user the entire node or
yes.
the entire GPU card. They want to split
Yeah.
it up because, oh, they're doing this set of users is doing development. They just need a quarter of it.
Yeah.
That's why that's important. Yeah.
Because there's still
But then
not just GPUs, but the proper H200s, the very specific data center GPU units that NVIDIA have and everyone else is bringing out. They're very, very powerful, platforms. And so just giving it to one seems like it's not the most efficient way to do it. And
Well, there's a
matching,
place for that. When you run a process into production, right? And now you need to scale out, your workload across multiple
yeah,
GPUs or multiple nodes, then yes, you need the whole node and do it. But when people are developing, that's not always the
yeah, it's
case.
interesting.
These things are very expensive and, uh,
Yeah,
oftentimes people are resource constrained. Yeah.
going back to the Kubernetes stuff, I think what's interesting there is that you're abstracting a lot of the difficulty and going back to your first points around, trying to make things more efficient for the infrastructure people and the actual end user. Kubernetes can be quite scary for even the most hardcore type of infrastructure guy that's traditionally infrastructure and say virtualization. They come to Kubernetes
Mhm.
and they struggle just with the construct. So to abstract and overlay and orchestrate a little bit of that, I think it's quite smart as well because you're just reducing the friction and the time to actually
Yeah,
get to that
exactly.
actual endpoint.
We're, reducing friction, reducing the complexity, letting these infrastructure teams kind of flow into really, I see it, they can just kind of roll it in these systems, Kubernetes systems as another natural extension of their existing infrastructure. And that's kind of a big differentiator, I'd say, for us, where we've supported those other infrastructure types for a long time,
Hmm.
and now great, Kubernetes can come along, you can slide it in exactly as the other ones work, user
Yeah.
experience wise.
And maybe a final question to lead into that. So, how have you seen the profile of I guess, the data scientist or the high performance compute user evolve over time? As a bit of a sort of, you know, interesting question. Like, and what are they mainly focusing? At the start, you talked about physics, right? Is physics still what is mainly being consumed and used on the system, or has the profile changed a little bit?
I think it depends a lot on the organization. I'd say a lot of the enterprise research organizations and the groups that have been using and consuming HPC for sometimes decades, that, hasn't changed too much. I feel like the end users themselves maybe evolve. And, before using HPC was a lot about, okay, I need to know the terminal and I need these batch commands and be able to get into that. Tools like ours make it so that the barrier is lowered for, people coming right out of school can kind of get up and start running on these type of things. The work has been evolving. These type of enterprise research organizations are buying accelerator and GPU systems or renting them to really augment or replace their physics code models. So it's the same, they need to be able to do the same type of virtual testing for physics, but now they're augmenting it with ML inference models instead of having to crunch the actual math numbers. So that's been happening a lot, and then I'd say as that world moves now to more, AI forward organizations, maybe groups you wouldn't conventionally think of as, consuming computing for R&D, they're buying these type of systems as well and figuring out how to use them. And it's maybe doing machine learning, image detection or object detection so they can roll it out in their stores across all their camera systems for some type of analytics on the systems, like, inside of the
Yeah.
stores. It's changing the applications a little bit, but the actual pipeline development and, the end user that are consuming the resources, they're still there. The tools they're using are maybe evolving, but it's the same type of profile, at least I think.
Get it? Yeah. Well, it sounds like it's well used. The use case is there, and obviously it's growing as well. And it's great to see you guys doing very, very well. So, just as a final note, I mean, what does the future look like for Parallel Works? Like, where do you feel you're going to be in 2 to 5 years? Is quantum? I mean, this has been a little bit of a quantum sort of period of time. It's starting to get that hype cycle, pumping a little bit.
Totally.
So,
Yep.
I mean, where does this? Because this is where high performance compute leads itself directly into that.
Yeah, I mean, we're going to keep evolving with the infrastructure, right? So, I mean, we're already talking to some quantum companies that, ones that make on-prem quantum systems and then also let you rent them, about folding that in as another, again, infrastructure type for us that
Wow,
as
yeah.
organizations start adopting those and values found, they could start just assigning tasks onto those. And there will be certain sets of tasks that are designed to run on those and bring value faster, right? There's going to be an
Yeah.
aha moment when that
It's
happens.
kind of scary, isn't it? Like I've been reading a little bit about that recently, and it seems like the photon versions of quantum computing are the ones that are potentially going to be a little bit more mainstream, if you can say that, because they don't run as hot and less error rates, and the qubits don't error out. So yeah, it's an interesting part of the world that we're all going to evolve into, and I'm sure you're going to be right there, center of it, in terms
That's
of
the
when it
goal.
starts
Yeah.
to pop
To
up.
us, just like an accelerator system, it's almost like a new type of accelerator. It folds in. There's a different scheduler
Beautiful.
interface to interact with it, but now,
Yep.
great, you can just assign tasks there. And for us, eventually, I see us becoming kind of this engine that helps organizations and then the end users place their computing tasks without having to like explicitly assign them to a place. It's like, where's the base place to run based on, these policies or objectives like cost or performance or power availability, or,
Yep.
it needs this type of task, or, oh, this can run out of an edge. I want our system to be the type of thing that helps, organizations deal with those type of questions.
Great end, Matthew. Hey, this has been a really, really interesting conversation. I'm glad that we've been able to chat about Parallel Works and what you guys are doing in the space. It's fascinating. I love the orchestration. I love that you're bringing together, you're solving complexity, which is all about doing great things with great tech. So, Matthew, thank you very much for being on episode 103 of Great Things with Great Tech.
103, great. Yep, Anthony, thanks for having me. Good conversation. Appreciate it.
Awesome. Thank you. Hey, just as a reminder, thanks for listening to this episode. Stay tuned for more episodes where we continue to highlight companies and technologies shaping our world. Don't forget to follow us on social media at GTWGT Podcast and visit gtwgt.com for more great content and all past episodes. If you enjoyed this episode, make sure to subscribe on your favorite podcast platform and on YouTube. Please spread the word, and if you feel like it, drop a review. Thanks for joining us, and we'll see you next time on Great Things with Great Tech.